Logarithmic equation is an equation where a variable appears only within a logarithm. There are two types of logarithmic equations that we'll discuss in this course. The first type are equations that can be reduced to the form logarithm to the base a of u equals b, where u is an expression that contains the variable and b is a real number. For example, if we have equation ln of x minus 1 plus ln of x plus 1 is equal 3, this is the equation that can be reduced to this form. The second type of the equation is the equation that can be reduced to the form logarithm to the base a of u is equal logarithm to the base a of v, where u and v again are expressions that contain the variable. The example of such equation is log to the base 2 of x plus 3 plus log to the base 2 of x is equal log to the base 2 of 3x plus 4. These are logarithmic equations, and since logarithms have restricted domain, before we do any solving, we'll have to find the restrictions on the domain, regardless of what kind of equation we are looking at. The second step is to write the equation in the appropriate form. So, for example, if I'm looking at the first equation, this equation is not written in that form logarithm equals a number, but it can be quickly done by using properties of logarithms. We have the sum of two logarithms on the left. The sum of two logarithms is the logarithm of the product, and therefore we'll get quickly equation logarithm equals a number, which will be in the form ln of x squared minus 1 is equal 3. So the second step in actually both equations is the same. We need to use properties of logarithms to rewrite the equation in appropriate form. In the first type, you'll have to expect a number that is left without a logarithm, like the 3 on the right hand side. In the second type, that number will not appear. All terms can be combined in such a way that on the one side equation you will have logarithm, and on the other side you have logarithm with the same base. For the first type of the equation, once we arrive to the right form, we change this equation to the exponential form, and we'll solve this equation for x. We'll obtain algebraic equation, and we'll apply whatever method will be needed to solve that equation. For the second type, we'll use the fact that logarithmic function is one-to-one. So we'll use the property that if the two logarithms with the same base are equal, then the inputs are equal. Therefore, we can write here that x times x plus 3 will have to be 3x equal to 3x plus 4. And again, we obtain an algebraic equation that we'll have to solve using appropriate methods. There is one more thing that has to be done after we solve our algebraic equations. We have to check that the solutions that we obtain solving those algebraic equations satisfy the restrictions that we find in step 1. And therefore, we'll check whether those solutions are in the domain of the original equation. If not, then even though they are solutions of algebraic equations, they will not be solutions of logarithmic equations. We'll look at those two types of the logarithmic equations in more details in the subsequent videos.